Imagine a future where energy is as abundant and clean as the air we breathe. Cities float among the clouds, we travel to distant planets, and our biggest dreams are powered by the sun itself. Our sun, a colossal nuclear fusion reactor, releases more energy every second than humanity has ever used. Yet, Earth captures only a tiny fraction. Most of it is lost to space. What if we could harness it all? What if we could build a structure so grand it would redefine humanity? With that power, we could solve climate change, end droughts, and feed billions. We could simulate universes, explore the cosmos, and secure our survival. This isn't just about keeping the lights on, it's about elevating civilization. The dream of capturing the sun's full power has a name, the Dyson Sphere. It's one of the most ambitious engineering projects ever imagined. It challenges us to see the stars not just as distant lights, but as resources for our future. The journey to this future starts with a single powerful idea, an idea that dares us to reach for the stars. Literally, let's explore how this dream could become reality. The Dyson Sphere was first imagined by physicist Freeman Dyson in 1960. He asked, "What does an advanced civilization need most?" The answer, energy. As civilizations grow, their hunger for power outpaces what a single planet can provide. The logical next step, tap into the energy of their star. Science fiction often shows a solid shell around the sun, but Dyson envisioned something more practical, a Dyson Swarm. Picture trillions of independent solar collectors orbiting the sun like a cloud of robotic bees. Each satellite is a massive solar panel, soaking up sunlight and converting it to usable energy. The swarm can be built gradually, piece by piece, over centuries. Start with a few satellites, add more as technology advances. This modular approach is safer and more resilient. If one fails, the rest keep working. The Dyson Swarm is a scalable, achievable vision for the greatest power plant ever conceived. It's not science fiction, it's a blueprint for the future. Piece by piece, we could capture nearly all the sun's energy. That's the true power of a Dyson Sphere. Every leap in human progress has been powered by new energy sources. Fire, animal power, steam, oil, and nuclear energy have all fueled our growth. Our demand for energy keeps rising. Think of 8 billion people charging devices, heating homes, and traveling. As developing nations grow, their energy needs will skyrocket. Our future ambitions, colonizing Mars, building lunar bases, exploring the stars, require staggering amounts of power. Fossil fuels are changing our climate and have limits. Even renewables like solar and wind on Earth have constraints: weather, land use, and scalability. To become a spacefaring species, we must look beyond Earth. The sun is the ultimate clean, reliable energy source. A Dyson Swarm would shift us from planetary scarcity to stellar abundance. This leap would be as profound as discovering fire or agriculture. It's the foundation for a future where energy is no longer a limit. With stellar power, we could shape our world and explore new ones. How do we build a Dyson Swarm? Not by launching satellites from Earth. Instead, we turn to the solar system's vast resources, especially the asteroid belt. Asteroids are rich in metals like iron, nickel, and silicon, everything we need. Robotic mining probes would extract and process materials right in space. Mercury, close to the sun and rich in metals, could become our cosmic factory. Automated factories on Mercury, powered by solar energy, would manufacture Dyson Swarm satellites. Using local resources, called in situ resource utilization, makes the project feasible. The solar system becomes our mine, our factory, and our workshop. We move beyond Earth's limits, building with the matter and energy of space itself. This is how the Dyson dream begins to take shape. Who will build trillions of satellites? Not humans, but autonomous robots. These self-replicating machines would mine, manufacture, and assemble the Dyson Swarm. Imagine a single seed factory sent to space, building more factories, which build even more, exponential growth. Soon, millions of robotic workers and factories would spread across the solar system. Fleets of drones would assemble satellites in orbit, guided by artificial intelligence. The swarm would start as a thin ring, already boosting our energy supply. Over time, it would expand, forming a complex web around the sun. A central AI would manage the operation, ensuring stability and efficiency. Humans would oversee and innovate, but robots would do the heavy lifting. This partnership would drive the construction of our stellar future. With trillions of satellites collecting solar energy, how do we deliver it to Earth? The answer: wireless power transmission. Each satellite converts sunlight to electricity, then beams it as focused microwaves or lasers to receiving stations, antennas, on Earth or other planets. We already use similar technology for communication. This would scale it up for power. Energy could be directed anywhere it's needed: cities, starships, or distant colonies. The Dyson Swarm becomes a solar system-wide power grid. Abundant energy would transform society. Industries could move off-planet, pollution would vanish, and mega-projects like terraforming Mars become possible. Supercomputers could solve mysteries of science and medicine. With a Dyson Swarm, energy is no longer a limit. It's the fuel for a new golden age. The dawn of a stellar civilization begins. How do we measure a civilization's progress? The Kardashev Scale, proposed in 1964, ranks societies by their energy use. Type 1 harnesses all energy on its planet: solar, wind, geothermal. Humanity is at about 0.7. We haven't mastered our planet's energy yet. Type 2 harnesses the full power of its star, exactly what a Dyson Sphere achieves. With stellar energy, a civilization could colonize its solar system and reshape worlds. Type 3 controls the energy of an entire galaxy, billions of stars. The Kardashev Scale is a roadmap for our cosmic journey. Building a Dyson Sphere is the leap from planetary to stellar civilization. It's the defining act of becoming Type 2. The scale inspires us to dream bigger and reach higher. Our journey up the scale has only just begun. If Dyson Spheres are a logical step, maybe other civilizations have built them. We could detect them by their unique signature. They block visible light but glow in infrared. Astronomers now search for stars unusually bright in infrared but dim in visible light, a sign of a possible Dyson Swarm. In 2015, Tabby's star showed strange dimming, sparking speculation about alien megastructures. While dust is the likely cause, the search for Dyson Spheres is now a serious part of SETI. New observatories will scan the sky for these cosmic signatures. Finding one would be proof we're not alone, a silent testament to alien engineering. The search continues, and the universe may yet surprise us. The Dyson Sphere is more than a dream. It's a challenge to our imagination and ambition. It reminds us that humanity's greatest achievements began as bold ideas. Building such a structure will require global cooperation, breakthroughs, and generations of effort. But every solar panel, every rocket, every inspired child brings us closer. We are learning to work with the cosmos, not just live in it. The universe is not just to be observed, but to be built. When you look at the sun, see the key to our future. The cosmos has given us the laws of physics and a brilliant star. The rest is up to us, to dream, to explore, and to build. Our stellar future awaits.